So hi everyone, happy to see all of you here. So today I'm going to talk about the DSS high I/O bandwidth disaggregated object storage system for AI application. I'm presenting on behalf of the MSL group at Samsung Semiconductor. So we all know that the data are exponentially generating and it demands for high bandwidth and the high scalability. And the very application that we know, the very data-intensive application that we know is our AI or deep learning application. Also, there is large amount of unstructured data or object format data. So the Samsung DSS Storage solution, it provides the AI and deep learning application with a high bandwidth and disaggregated, easily scaled object storage system. So basically, the DSS is the disaggregated storage software, and it implements key value object on top of the NVMe over Fabric, and explicitly designed for object and support the remote access over the NVMe and facilitate the disaggregation of the resources between the storage and the computation. So if we want to just take a quick look at the overview of our architecture, is that we have this client server on one side that is running all these deep learning or AI application on their GPUs, and these all sessions are running, and then they will requesting some data over the network, and they will access to our object storage server with consistent bandwidth and high bandwidth with no congestion. So if I wanted to deep dive into the architectural design, there are three main parts into it. One is our object storage server, the network setup, and on the client's server side. So on the storage side, we have two different parts. One is the front end, which is basically we are using a MinIO, an Amazon S3 compliant open source object storage server. That provide the KV API for data store access. We modify it to make it consistent with our stack and in sync with our stack. And we are using the erasure data coding for the data consistency. On the back end, we have the NVMe over Fabric target stack, which provides the high performance KV value service, key value service over the RDMA. And the target application also, apart from the target application, we have this KV pool, which is the map one or more SSD, your bulk SSD into it. And then we also have the subsystem, which is basically like a namespace or container with aggregated performance. Another component on our back end is the UFM, which is the Unified Fabric Manager, and it's a lightweight ecosystem software which manages the fabric, discover any new devices, monitor devices, and configure network and devices. Also, it collects logs and stats so that the whole cluster works properly. So on the network side, the second part of our design is the network setup. So each of our storage server has 4 dual port NIC, and on the network stack, which supports 2 different basically protocol. One on the front end, which the application interacts with the MinIO, is our S3 traffic, which is coming. It's basically the TCP/IP S3 front end VLAN. And then on the back end, we have the Rocky network, which basically is the NVMe over Fabric protocol that accesses the subsystems. And client do not access to this backend one. So on the client side, we don't really need much apart from a client library that we have. It's a very lightweight set of API that the client needs to have it so that they can access to our storage system over the network. So basically, this client library facilitate the access using the S3 operator, put, get, and list and delete. And then it gets all the configuration of our cluster and figure out how to maximize the performance by load balancing all the data throughout our storage. We experiment on our design using a 10 homogeneous storage server and 16 clients. So you will see this is basically a specification for our storage server and client server. You would see that on each storage server, we have 16 4 terabytes PMI 733 SSDs of Samsung on it. And then when we run the S3 benchmark of 30 terabytes data of 1 meg or 2 meg object size, we get around like 180 or 275 gigabytes per second. We use both the with and without erasure coding, so that's the difference you will see with and without erasure coding for get. And then we see around like 26 to 38 gigabytes per second for the put and writing. So both of these tables, one is for 1 megabyte, the other one is for 2 megabyte object size. So for the 1 megabyte, we can only measure the no erasure coding, not for the 2. So as a conclusion, we can say, so this DSS storage solution of the Samsung is provide the key value API, and it's a new object storage system that feature a deterministic high I/O bandwidth and with a scalability over both your computational side and the storage side, and the throughput that you will get for the read is around like 180 to 275 gigabytes, and for the put is around like 26 to 38 gigabytes per second. In future, we are working to improve this storage system by eliminating some of the overhead that we have over the network. So yeah, with that, I would like to thanks all, and yeah.
Thank you, Masa.